everybody. Wouldn't it be great if I was in a Tin Man costume? Yeah, I don't know how I'm gonna follow that story with my talk. I wasn't really prepared. Yeah, welcome to my talk, CSS algorithms. I'm really excited to be giving this to a room full of people at a JavaScript conference. And I think the best thing is that I've met so many great people that I'm like, oh, I'm giving a talk to all of my new friends. Isn't that nice? Okay, anyways, friends, before we get started talking about CSS algorithms, we have to answer a very important question. Is CSS a programming language? Fire emoji. How many of you have seen this question or like related drama about this topic on Twitter over the last year or so? Yeah, okay. Depends how many people use Twitter, I guess. Well, I do have a question. Like, does this drama come up in real life also, or is it mostly contained to Twitter? Okay, anyways, we have to answer this question before we talk about algorithms. So I asked this question on Twitter first in March of 2018, before I gave version 1 of this talk. So this talk is on 3.5.1 now, I believe. So is CSS a programming language? What did Twitter think in 2018? Any guesses? No. So, but it's pretty split. So we got 42% yes, 50% no, 8% I'm not sure. Not a huge data set here, 129 votes. But the answers to the kind of responses in the comments were very varied. So it was like either yes, absolutely, or of course it's a programming language, or I don't really consider CSS programming, or you can't call styling a web page programming. It's not really a programming language, things like that. So after I'd given this talk a little bit, before I started giving it again this year, in May of 2019, I asked this question again. And I was like, oh, nobody's going to answer. They're going to be like, OK, Lara, we see what you're doing. Like, we saw your talk. Like, OK. No. This time, the poll had 5,324 votes, which is definitely the most activity I've had on a tweet before. And the no's increased. And I was like, what's happening? What's going on? And not only were there the same kind of varied responses in the comments, but there were also people that kind of specialize in HTML and CSS that were saying, like, I never call myself a programmer, or things like, why are we concerned about what CSS is? We should be concerned about like what it's doing, et cetera. And things like, stop asking this question. Don't wake the beast. So stop, like everybody, stop. We have to answer a different question before we talk about, is CSS a programming language? What is a programming language? Before we decide whether or not CSS is one of these things. So, not surprisingly, there are many fields of research and people who have dedicated their entire careers to answering this question. And we can't be really specific about what a programming language is because there are so many types of programming languages. So the definition kind of boils down to, there are lots of different ones, but it could boil down to a formal language for instructing a computer to perform tasks. So this is kind of like Wikipedia and several others, some good articles out there. The important part here is language. It's a language. And there are different types of programming languages, and these kind of fall under the categories of programming paradigms. And we use programming paradigms to both describe languages themselves as well as the style of code that we write. So the two main paradigms are imperative, which is code that describes how code that tells a computer how to accomplish a task, and declarative, where you tell a computer what to do. So the language, the expressions in the language are saying what, not how. And the main difference is the presence and absence of control flow. And so control flow is the ability to manipulate the order of executions of statements in a program. So control structures like if statements, for loops. Imperative languages have these, declarative languages do not. Any logic or iteration is baked into the statement itself. What are some examples of these programming languages? Imperative languages, JavaScript, of course, Ruby, C++, Python. These are what we usually think of when we think of programming languages, so oftentimes general purpose languages. Declarative languages are often, not always, domain specific. So they are built to function within a certain context. What are some domain specific declarative programming languages? SQL. So SQL is a domain-specific declarative language for programming databases. HTML is a programming language for adding meaning around content on a web page. CSS is a programming language for styling that content on a web page. So, loud and clear, CSS is a domain-specific declarative programming language. 100%. CSS developers program the layout of web pages. Boxes. Let's be honest, everything is a box. CSS developers are box programmers. Also 100%. Okay, so cool, like, great, like maybe I could win a Twitter argument at some point. Good job. Like, why do we care about this? Why do we care if CSS is a programming language or not? So I want to talk about something called turd-driven development. Okay? Of course, this is a riff on test-driven development. And one assumption in test-driven development and turd-driven development is that all code is crap the first time you write it. So it is not possible, like, for a human being to write perfect code the first time you write it. So in test-driven development, we kind of counter this by starting, instead of writing your production code, you write a failing test first. So in CSS, we don't really have this kind of testing. So you could kind of say the test is the design. So like, okay, this is my failing test. Like, yes, I see it. It doesn't exist yet, so yes, the test is failing. Run the test with our eyes. So what do? We write code to make the test pass. So all code is crap at first. We write some crap CSS. And then what happens? We stop. Okay, wrote the CSS, it's done. I don't have to write it anymore. We wait. And then, oh wait, our test is failing. There was a change to the UI. Some new feature, our test is failing now. So what do? We write more CSS. Our test is passing. Oh wait, maybe there was a regression. So now our test is failing again. So we write more CSS. And then, okay, whew, don't touch it, everything's working. And then we wait. And then, oh, new feature, more CSS. Test is passing. Oh no, another regression, more CSS. And so on. Wait, here we go. Oh wow, what's happening? Our test no longer completely passes, and this is what happens. But the problem is this is the web. This is the front end of our web applications. This is what people use. And this doesn't just apply to CSS as a language, but also HTML and also JavaScript. It's kind of this culture of how we program. So what do? Like, ooh, this is so bad. It's so bad. All this crap everywhere. So what do? Stop writing CSS, start programming. Okay, so the thing is, programming does not equal logic, math, science, engineering. These things can be part of programming, but programming in its essence and like as an art, as a craft, is writing instructions for computers that other developers are able to read and maintain. And I think if anything shows that CSS is a programming language, it's that naming is really hard and extremely important. Naming is one of the hardest problems in computer science. Like, CSS is part of that story. Unless you're writing CSS and JavaScript. Okay. No shame. Okay, so cool, we got it. We covered a lot of ground so far. Now let's talk about algorithms. Now that we know CSS is a programming language, how do we write algorithms in this programming language? Algorithms 101. Let's have another definition. An algorithm, a well-defined computational procedure that takes input and produces output. This is from Thomas Corman, who wrote the book called The Introduction to Algorithms that is assigned in many a computer science course. I read the introduction. Might revisit. Okay, so well-defined computational procedure, input and output. Let's use this little board to help us visualize. So common use for an algorithm, sorting. So we have an unsorted number, a list of unsorted numbers. Our algorithm, the output, our algorithm should transform that input into sorted output. What are some sorting algorithms? I think this crowd probably knows some sorting algorithms. Bubble sort, selection sort, merge sort, quick sort, and could go on, but we'll keep it at that. Okay, what does an implementation of a sorting algorithm look like? Name that sorting algorithm. Bubble sort. Okay, so this is imperative JavaScript. We'll give it a heart. That's cool, that's fun. So if this was declarative code, we would just see this bottom line. So the algorithm itself would be obscured behind the call. So we're saying what, we're not telling the computer how to do it. What about another kind of algorithm? So how could this possibly apply to boxes? Okay, so our input is a stack of unsorted, unstyled boxes. And our output, we want this to be a row of boxes. What kind of algorithm happens in between? Well, display flex, absolutely. Float left, gasp. How dare we? Yes, floats still have their place in this day and age. Okay, what does an implementation of one of these algorithms look like? Well, this is what we see. This is declarative CSS. Like, yes, there's a big, huge algorithm under the surface there, but display flex, that's all we have to write. That's pretty cool. What about adding some kind of logic into this algorithm? So if we expand on it a little bit, this is what declarative logic looks like. So we're saying what, we're not saying how. And under the surface, this is what is happening. So this is a little snippet of Rust code from the experimental rendering engine called Servo that's kind of being slowly pulled into Gecko and Firefox. And this is a little line that I think is potentially where flex wrap is happening. So there's this imperative backbone to any declarative code that's written in CSS. Let's have an iceberg metaphor. Love a good iceberg metaphor. Okay, declarative, CSS on top. And we have our imperative code on the bottom. Oh my God, so many algorithms in here. Browsers are extremely complicated pieces of software. What about up here? Can we call the CSS we write algorithms? I mean, algorithm? Why not? So that's kind of the premise of a lot of the work I've been doing. Why not? Like, what happens when you call that an algorithm? Like, how far can we take this? So let's update our Algorithms 101 to CSS Algorithms 101. Domain-specific, declarative. So these are like the magic words for the kind of safe words, magic words with CSS. Like, and in terms of using a word like algorithm or any kind of analogy to general programming, it's like by definition going to be different in CSS, domain-specific, declarative. You have to understand the domain in order to use these things. So a definition. A CSS algorithm is a well-defined declaration or set of declarations that produces a specific styling output. Me. So key points here. Well-defined and specific. An algorithm is not a block of however long a set of declarations can get, but you're solving a specific problem. And I also think an algorithm is kind of when CSS goes from being this mundane styling language like font size, color, whatever, to something where you're like, whoa, CSS, like what's happening? This is so cool. And you kind of appreciate the fact that like you don't need to write so much code because the language is doing it, and we can understand the language and understand how to communicate with the browser. So you know what this notion is, this well-defined set of declarations. So as I was thinking, I was like, okay, pick out some common algorithms that people would recognize. And the first one I thought of was this, clear fix. So, and I was like, oh God, sad face. Like, that's a hack. Clear fix is not like a fun algorithm. It could be an algorithm. Okay, what about this? So this is a very long class name, and not actually the name of the class, but I get the idea. And this is very amazing and elegant that you can do this. So let's say you have an element way out here, positioned relatively. You can pick, like, no matter how far it's nested into that child, you can kind of pop out of that whole DOM structure and stick it to the top right, bottom right, whatever. That's cool. Positioning, it's cool. Spaced content. Has anybody used this before? This is kind of a selector pattern. Lobotomized owl. Someone named Hayden Pickering came up with this, but this is a very elegant way of spacing child content, spacing content within other content without adding to the top and bottom. This one I like. It's kind of fluid typography. So we use a viewport unit to make the size of a text element more fluid. And this is like linear interpolation, math, cool. CSS grid, oh my God. these 2 lines of code, we can make like so many grids. Add a couple of spans in there, and this is like the most robust grid framework you'll ever need. It's not a framework, it's just code. Oh my God, so great. Okay, so CSS, well-defined declaration or set of declarations, potentially also selector pattern, but I haven't officially updated the definition. Also could say a CSS algorithm is a utility pattern that lets the browser algorithms do the work. And I think a CSS algorithm also follows some programming best practices. So the single responsibility principle. Let's say we have a set of kitchen tools. So the wooden spoon is so good at being a spoon. The whisk is great at being a whisk. Spatula is great at being a spatula. Knife, etc. What happens when a tool tries to do too much? Sad. This is a spork. A spork. I'm sorry, spork, but you're just trying to do too much. It's not that useful. People aren't like that excited about sporks. Although there is a restaurant in Pittsburgh named Spork, and I'm like, why did you do that? Okay, anyways. Small, well-named functions. This is a good programming practice. How small should your function be? Small. And then smaller than that. So these are the words of Robert C. Martin in a book called Clean Code. He's kind of one of the inventors of a lot of agile software development practices. Okay, this is all well and good, but what about in the real world? You're probably not writing the next clear fix. So I work as a design engineer at a company called Penske Media Corporation, PMC, and we're a big publisher with 24, I think, different very large brands, all on WordPress sites, which is exciting, kind of this enterprise WordPress environment. Sometimes I call myself a design ops engineer, and I love my job, so I'll give it some hearts. These words also equate to UI engineer. Also, the design systemser at PMC. Also, the first and only front-end developer in a team of many back-end developers. However, not anymore. We hired another front-end developer recently, and I see that as like a major sign of success. I'm like, yes, a company that like went so long without front-end developers now has 2. This is cool. This is like, yes, PMC cares about front-end. So my work has revolved around the development of a design system called Lara. So yes, it is called, our design system is called Lara. And it is an embryonic design system. So Lara is kind of a good name for it because it's like a little baby. It's not this beautiful UI library of components, but it's more like tools and best practices to build modules and build components. So embryonic design system. And this has really been like a laboratory for me to try out all these ideas about like what is an algorithm? How does this work? So Lara was born inside of a project for a redesign called, for a site called Deadline. And this is a WordPress theme, kind of the base file structure here. And then drilling into a source directory. This is an ITCSS architecture, inverted triangle CSS. And I added, at the beginning of the project, added this directory for algorithms. I was like, will this be useful? Will this really be, will we actually add anything to this? And yes, there were like 20-something algorithms in here afterwards. So kind of proved to be this useful naming convention and useful way to think about styles. And since this project completed, the process has been like moving all of this code into a shared repo. So a project structure that might be familiar to some is the monorepo structure. So this is like Lara 1.0. And then these are NPM packages. So we have kind of the CSS NPM package. And inside one of these algorithms, so a glue, which is a pretty weird name for a style. There's a SAS file or a CSS file, and then an HTML file to kind of give an example of what the markup is. And a glue is this algorithm. But we've kind of turned it, like design systemed it to be more reusable and a little more robust. So it has some different namespacing, and we use the term glue because it's like a nice little mental model for what this algorithm does. You like glue a UI element within another UI element. And this was used like 15 times in the Deadline project, not only by me. Mostly not by me, in fact. So there was another contractor who was like a little more junior, and they understood what this did. And I was like, whoa, this could be a really cool way to kind of communicate these CSS concepts that might be a little harder to understand at first. Another algorithm, space children. Ooh, space children. So this is the lobotomized owl. And design systemed, this looks like this. So I can have some progressive enhancement inside this algorithm. And so the idea of like kind of pulling this functionality into its own little node, we can do into its own little section, we can do really interesting things. So column gap is a new property that's in some browsers, and we can add this feature query inside the algorithm. In markup, this is what it looks like. So we have pretty heavy use of utility classes, and the algorithms are kind of layered in among the other class names, like an onion. The algorithms can also be useful for stuff like this. So if you've ever gotten a design and you're like, God damn it. This is a really pretty border, but like this is a very annoying thing to build. Why do I have to build this? So you can be like, I'm gonna pull this out. I'm just gonna write this border code. And if it shows up in one design, it's probably gonna show up in another one. So an algorithm can be a nice way of handling that. Okay. How to write a CSS algorithm, or realize you don't need to. How do we write algorithms? How do you write an algorithm in an algorithm interview? Has anybody done a whiteboarding interview or an algorithms interview? A few? Yeah. No more comments. Okay. So the steps, these are kind of taken straight out of cracking the coding interview. Plan your algorithm. Then you write a brute force solution, so a not optimized version that kind of steps through piece by piece. Slow, but maybe it works. And then you do a walkthrough in the interview to kind of make sure the algorithm is functioning, and then you optimize it, kind of layer in different optimization techniques. What about writing CSS algorithms? Well, you start by planning out the algorithm. Then you write a brute force solution that's not quite optimized, but maybe works. Walk through and optimize. Same thing. Except there's some pre-work when you're writing a CSS algorithm, which is doing a turd check. So you need to stop before you write any CSS and say to yourself, should I actually be writing new CSS? Like, what is going on? Have I solved this problem before somewhere in this code base? And why can I not use that again? So just a quick moment to be like, wait, is this really the problem I should be solving? And then you plan. So pseudocode some boxes, pseudocoding CSS. And defining your problem, figuring out what you actually, like, what is this thing you're having you're having a hard time with that you need to solve. On paper, I love drawing boxes on paper. I love doing other things too, but sometimes this is really fun. Also because like writing things on paper and like whiteboarding, there's research that shows we have better, like human beings have better retention when you're doing things in physical space like that versus drawing boxes in Illustrator, et cetera. Also printing out the design and marking it up in that way can be really useful. Figure out what, like if you're working with an existing system, what patterns are already provided, what do you need to write new? Then we have a brute force solution. Spaghetti, write some gross code, that's fine. And remember our assumption, all code is crap at first. So don't write it in the actual style sheet. Write it somewhere else. So instead of writing it kind of inside the main application, you could have a separate file. So something that I tried in this recent project was having a file called scratchpad.scss that was added to a test environment, not to the actual application. So it was a safe space to try out the CSS. This is what it ends up looking like, working with boxes. CodePen is like a product for this specific use case, for writing front-end code outside of a regular environment. And this is the little border arc, or story border arc from before. Then you do a walkthrough. So like we love resizing our browsers, right? Web developers are like, yes. I'm not gonna test it in a different browser, but I'm gonna resize it a lot in this one. So that's a walkthrough. But test it in other browsers, and it's a lot easier to do that when it's a small piece. So it's easier to do it now. Ask yourself, is every declaration essential? Are there any dependencies? Like, does this algorithm need to be applied with another class, and why? And then you can have a little Robert C. Martin in the back of your head that's like, smaller functions. And then you optimize your code and refactor and document. And this is when the magic happens. So our poopy code becomes a beautiful flower. Of course, this is how programming works, right? And this is when you're moving that crap code. The fact that you need to move it into the actual code base, that refactoring will happen naturally. So moving from this set of boxes to an actual layout will improve your code. Document. So inside the deadline pattern library, we had these algorithms documented, just a little paragraph about what it's doing, how to use it, and then boxes show what it's doing. So I feel like with this process, turd-driven development can kind of become more like test-driven development. With CSS, what? So what if we had thought about it like, oh, our test, instead of being the entire design, is a smaller piece of the design, or a specific piece. So we run the test with our eyes still, and we write our crap code, but the refactoring, which is integrating it into the actual code base, can kind of keep that, give us that additional step of refactoring. And so, once again, morph into a beautiful flower. Refactor, the missing piece. So let's be real. Yeah, right. But less looking poop is greater than regular poop. OK. So, but what if? So this is a little experiment that's coming up here. What if, so test-driven development. I've been writing tests for other parts of our design system in JavaScript, and I'm like, I love writing tests. There's some magic, like straight up magic that happens when you write good tests. And I want to do this with CSS. So like, how can we write unit tests for CSS? Domain-specific declarative unit tests. So I had an idea, and I wrote a couple of very enthusiastic blog posts about it. Testing CSS algorithms. How can we do this? So, warning, this is a big code slide and kind of a prototype of something I'm trying out with a little bit of client-side JavaScript for what a CSS unit test could look like. So this is essentially a couple of like test methods that log to the console, and the crux is that you're testing boxes against boxes. So you're figuring out the relative values of certain positions in boxes and comparing them. And what this looks like in practice, so a unit test might be with the minimum amount of HTML, and we're logging to the console. But this could also be an integration test on an actual application. So I added this to the deadline staging environment and actually found a problem with this. So this showed me that there should not be space below the last item, but there was a different set of styles that was adding that space, which is incorrect. That will cause problems later, because if someone adds another widget to this sidebar, it's going to be too spaced out. And that's what causes this like turd-driven development, especially with CSS, where you're like, oh, you overwrite it instead of like going back to change the actual issue. This could be cool. So my inner critic is like, over-engineering much, Lara? Like, why are you, like, it's just CSS, jeez, my God. But then I'm like, no, that's the kind of thinking that causes turd-driven development. Like, say no to that. Like, it's okay to think about CSS like this. And in fact, like, the rest of software has come up with many an antidote to turds. So general software on this end is kind of like, whoa, look at all these things we do to control our code, to create better development environments and develop better programming practices. And then on the other side, we have like front end and UI that has a lot of these things as well. So design systems, atomic design, progressive enhancement, many a CSS architecture and naming convention. And maybe these things are not that different. So there's a lot of the same concepts that bridge these two kind of areas that could seem separate. But testing, I think we could do more of this. Okay, conclusion. Let's have a small story time. Okay, how the math hater became a programmer. This is me, 14-year-old Lara in 2003. I hate math. I was a staunch math hater throughout my childhood. I loved art class and horses and llamas, but at the age of 14, I was starting to become a little bit anti-llama and just kind of embarrassed about that. But I loved art class and horses and Green Day, which I didn't put up there. 2009, a little bit larger, Lara. I had some blonde in my hair and glasses. I was in college, 20 years old, in art school. And I had a weird idea for a video game, and I learned to code because I had a lot of freedom at school and very supportive parents. And then fast forward to 2015, I'd been working as a freelance developer for a while, and I wrote this article for CSS Tricks. So, Tales of a Non-Unicorn, story about the trouble with job titles and descriptions. And this was about a job interview I went on for a role that was, I think the title was UI engineer / interaction designer. And I was like, yes, this is totally my thing. HTML, CSS, maybe some design, some like UI-oriented JavaScript. And in the interview, they asked me FizzBuzz. And FizzBuzz, for anybody unfamiliar, is like this sort of beginner's algorithms question. And in the interview, I was like, what? Like, why would anybody do this? So I had been so far removed from what this kind of algorithms interview culture was in computer science as someone who is self-taught from an art background. And after I wrote this article, which kind of became a little bit viral, there was a post on Reddit. Someone retitled it to, "Designer applies for JS job, fails at FizzBuzz, then proceeds to write 5-page-long rant about job descriptions." I was like, whoa, and this was like on the front page. There were all these horrible comments coming into the article, like awful stuff. And so after this experience from like 2015 to 2017, I was like, oh, hell no. Like, I am not a programmer. Computer science is not what I do. I do HTML and CSS. Computer science, not for me. Programming, that's not what I do. Like, who are these people? No thanks. So I kind of had these 2 years of like rebellion against that kind of identity. And then late 2017, I ended up getting an interview for a job I was super excited about that was going to be an algorithms interview. Like, no question about it. And so I was like, okay, I gotta learn this. Swallow my pride, FizzBuzz, let's do it. So I wrote all these blog posts and kind of put myself through this like computer science boot camp. And as I was doing this, I was like, wait a second, this is for me. Like, this is cool. I love this stuff, and it's not so different than the concepts I work with in HTML and CSS. And in 2018, I proposed this original talk of algorithms of CSS for CSSConf EU that kind of posed the challenge to bridge the gap between CSS and computer science. And throughout that talk, CSS went, something I knew well before, kind of went from like CSS to like, wow, I understand what CSS is doing. Like, this is freaking amazing. I love CSS. And I realized that this is kind of the wrong metaphor. It's not like this. It's like this. So computer science is like the big, like, you know, mama giving everyone a hug. All these nice things in here. So CSS, they're all together. So to put a button on this, here's FizzBuzz and CSS. Thank you. Okay, 2019. Is blank a blank? Is CSS a programming language? This is like a fucked up question structure. It is, because you can sub out these terms, and we have, is depression a treatable illness? Is non-binary a gender? So when you ask a question like this, it's kind of opening up the option for people to say no when having these exclusive definitions. As soon as you start excluding something from something else, that's a sign of much darker stuff. So this is a smelly question. This is a culture smell. The answer is, of course. So I'm like, what is going on? Why is this happening? Why are there designers designing systems at companies, but they can't have anybody from the engineering team implement them because HTML and CSS are not considered part of engineering? Or why are there developers coming from full stack boot camps or presenting themselves as full stack developers who don't understand fundamental characteristics of CSS? Like, is CSS not part of the stack anymore? What about, like, what's going on? So I was describing this to someone at my co-working space, kind of this old school computer science guy, and I was like, his name is Dick, and I was like, what? Like, why are there so many people that don't think CSS is a programming language? Like, what's going on? And he's like, well, Lara, when it comes to computer science, anything computer science, there's an 800-pound gorilla in the room, and it's called testosterone. And I was like, okay, Dick from my co-working space. Wow, okay, so maybe this is the truth. Like, is this what, like, okay. But I don't think the answer is to not talk about it. So when I see responses to this question, it's like, stop asking this question, don't talk about it. It's like, questions like that can also be good because it brings out maybe what we need to address. So what if, instead of people who know other types of programming not learning HTML and CSS because they're not programming, I know programming, I don't want to learn that, it's not my thing, and then web applications suffering because of that. That's kind of on one side. And then we also have people like me, and I'm sure some people in this room who maybe were focused in HTML and CSS and kind of told you're not a real programmer, and therefore you develop this kind of oppositional identity where you're like, okay, well, I'm not learning that. I mean, that was me. What if we thought about it like this? So like CSS and HTML are this kind of little golden springboard. So we have little people like me, little baby Lara, or people who with non-traditional backgrounds, who don't necessarily have the ability to go into computer science programs, et cetera. HTML and CSS can be this kind of springboard into technology. So, and not just people that look like me. Of course, like anybody can do this. And it's also kind of a metaphor for creativity, because I'm not that good at drawing people, so I put a monster in, and I was like, well, it has to represent something. But creativity, like, let's have more creativity in technology and on our engineering teams. So HTML and CSS, like this golden springboard. So my question is, like, why aren't we valuing these skills more, and why aren't we embracing these as programming? And instead of saying, like, oh, this is not for you, say, yes, you are a programmer. Come, learn more. Thank you.